Hi, this is Rohan from educator.ai. Let's dive in. When a large language model, an LLM, writes an essay or answers a question, it can feel like magic. But underneath, it is doing one small thing over and over. In this video, we build an accurate mental model of that one thing, predicting the next token. Here is the whole job. You give the model the text so far, and it decides what comes next. Not the whole sentence, not the whole answer, just the very next chunk. Everything else you see is that single decision, made again and again. A quick word about the unit. A token is a chunk of text, often a whole word, sometimes a word piece, each mapped to a number called an ID. The model never sees raw letters. It sees this sequence of IDs. So predict the next token really means, pick the next number from a fixed list. Think of it like a giant score sheet. The model has a fixed vocabulary, tens of thousands of possible tokens. For the text so far, it hands out a raw score to every single one of them, saying how well each would fit as the next token. Those raw scores have a name, Logits. After the text, the cat sat on the token mat gets a high logit, rug a bit less, floor and chair lower still. Right now these are just unbounded numbers. They are not probabilities yet. They do not add up to anything meaningful. To turn logits into probabilities, we use a function called Softmax. 2 steps. Raise e to the power of each logit, which makes every value positive and blows up the big ones, then divide by the total so everything sums to 1. Out comes a proper probability distribution over the whole vocabulary. Let's confirm it with real numbers. 4 logits go in. We exponentiate each, divide by the sum, and print the result. Notice, the largest logit, 2.0, gets the largest probability, and every value adds up to exactly 1. That is Softmax, no mystery. After Softmax, the bars mean something concrete. The probability that each token is next, mat at 55%, rug at 22%, and so on. To actually generate a word, we now sample from this distribution, draw one token, using these probabilities as the odds. We can tune how bold or cautious the sampling is with a knob called temperature. We divide the logits by the temperature before Softmax. A low value like 0.5 makes the differences bigger, so the top token dominates. The output gets more predictable, more focused. Great for facts and code. Turn the temperature up to 1.5 and the opposite happens. Dividing by a larger number shrinks the gaps between logits, so the distribution flattens out. Now the underdogs get a real chance. The text becomes more varied and creative, but also more likely to wander off or make things up. Temperature alone can still occasionally pick something absurd. So we add filters. Top K is the simplest. Keep only the K highest probability tokens, here the top 3, and throw the rest away. We renormalize the survivors and sample only among them. No matter what, the tail of nonsense tokens can never be chosen. Top P, also called nucleus sampling, is smarter about the cutoff. Instead of a fixed count, you keep the smallest group of tokens whose probabilities add up to P, say 90%. When the model is confident, that might be 1 or 2 tokens. When it's unsure, many more. The cutoff adapts to the moment. Here is the loop that turns one prediction into whole paragraphs. We take our chosen token mat and append it to the input. Then we run the model again on the longer text to get the next token. This feedback process is called autoregression, generating one token at a time, each one becoming part of the next question. This toy version shows the whole mechanism end to end. Softmax the logits, sample one index using those probabilities, record the token, then nudge the logits and loop. With a fixed seed, it prints the same sequence every time, proving that generation is just sampling in a loop, nothing more. A few traps. The model does not plan ahead, it only ever computes the next token, so coherence emerges from the loop, not from a hidden outline. Temperature 0 isn't random at all. It always takes the top token, called greedy decoding. And remember, raw logits only become probabilities after Softmax. Use this as a checklist. Always Softmax before treating scores as odds. Lower the temperature for precise tasks, raise it for brainstorming. If you filter with top K or top P, renormalize the survivors, and never expect a single forward pass to plan an essay, coherence comes from the loop. So here's the whole picture. The model scores every token as Logits, Softmax turns those into a probability distribution, and we sample one token. Temperature, top K and top P, shape those odds. Then we append the token and do it all again. Predicting the next token, in a loop, is how every LLM writes.